Hello everyone, I'm Chad Granum. I go by Exodus on CPAN, and this is my presentation on Test2. This is intended for people who are going to be writing tests, though we will go a little bit into some of the internals. So what is Test2? Test2 is the new framework that is a replacement for Test Builder. In fact, at this point, Test Builder is just a legacy wrapper around Test2. So if you have a fairly recent version of Test Builder, it's using Test2 under the hood. Nothing's really going to happen to Test Builder in the long run. There's no way it can ever be completely gotten rid of. There's just too many things that use it that will never be updated. But as I said, it is now just a wrapper around Test2. So these are old benchmarks. I actually haven't updated these in a couple years. So they're no longer accurate, but they at least give a basic idea of where performance is. Basically, the legacy Test Builder before converting to Test2 had a much quicker startup time. So whenever you'd start a test, it would go a bit quicker. But Test2 has a much quicker runtime. It can churn through a lot more OKs and other events than Test Builder could in the same amount of time. So if your test suite is a ton of files that take less than a second to run, legacy Test Builder would have been faster for you. But if you have test suites where your test files take a long time to run, then you're going to get a big benefit with Test2. You get an even bigger benefit if you use the Test2 tools directly instead of going through Test Builder, but there is still a performance gain when using Test Builder wrapped around Test2. But as I said, these benchmarks are pretty out of date. I won't swear by these anymore. So first I'm going to go into a tutorial about testing. This is a startup for anyone who's never done any testing, so it might be boring to some of you. Can I get a show of hands of who has actually written unit testing in Perl before? Okay, most of you. So I'm going to go through this pretty quick, at least this section. So first of all, you got the boilerplate. If you want to use Test2, the best thing to do is use Test2 : v0. This system allows me to make changes if I decide, oh, something I put in the initial test bundle isn't very good. I can come out in a year and release Test2 v1, and nothing that used the old version will break if I have to make breaking changes to the interface. But that loads a ton of plugins and other stuff. It gives you what I consider to be the most essential testing tools. So first thing you have to do is you have to make a plan so that Test2 knows that your test didn't exit early with an incorrect true value. An old way to do that was to just give it a number of tests, and it's still a way to do it if you have a lot of forking or threading. You might want to give it a hard-coded number just to be sure. With test more, you would list it when you imported test more. You don't do that with Test2. With Test2, it's its own separate declarative function, plan, and then the number. That's because I found a lot of bugs would happen when you try and set the plan at import time. So really not a good idea to do that anymore. Done testing is what I recommend. You put it at the end of all your tests. It'll output the plan automatically. You don't have to do any counting. And the fact that it got to done testing means that, yeah, the script did not exit early. Do not put done testing in an end block. That completely defeats the purpose of it. So skip all. Sometimes you have a test that won't run on Windows or won't run on Mac or needs certain things installed. So Test2 provides the skip all planning method, function. So all you do is skip all and the reason, and if you want to throw on a conditional, go ahead. Assertions. This is the meat of testing. Just like with test more, you get okay as your very simple, okay, this is true, or uh-oh, this is false. That means it's a failure. Comparisons. This is a spot where there's a big difference from test more, because test more, its is was just a string compare. With Test2, Test2-Suite specifically, is always a deep compare. So you can just give it an array and what you think the array should look like. You can also take strings, but essentially is equivalent to is deeply, but with much better diagnostics that I'll be showing you later. Like is similar in that like is now a deep comparison, but it's a relaxed deep comparison. Anything you put in the want section, so the second argument, it'll verify that is as expected, but it'll ignore anything extra. So if you give it a hash in the first argument and then the second argument give it a hash and only specify one key, it'll verify that key, but it'll ignore all the other keys. So it's a relaxed check. You can also just throw in a regular expression anywhere and it'll validate it. So you can do a deep regular expression check here. Just check that this hash key has cat in it. So cat will pass. So you get a relaxed deep comparison. And like I said, it's the right-hand side argument that defines how things are going to be. So if you put a reference to something in quotes on the right-hand side, then it will do a string comparison to whatever was on the left side. There's also a DSL, a special language to help you write these things. Here's an example where we're giving it this complicated array. And note, I'm intentionally making a test that fails here to show the diagnostics. So here's the array we're checking against. We're checking that it's an array. The first item is X, nope. Second item is Y, nope. Third item is a hash, yes it is, but inside the hash, we give it values that aren't actually here. This one here, DNE, means check that this hash key does not exist. And then N to say there should be no other fields in this hash, but there's actually 3 up here. So that check will fail as well. And then down here, we see what diagnostics it actually gives you when you have a deep comparison. Sure, this array passed, but look, you gave it A, but we were checking for X, and B, checking for Y. Then there was a hash, that was good, but this value didn't match. And here we got 1, but we were checking that it doesn't exist. And then the fact that we were also limiting how many keys are there, that also caused a failure. It doesn't cause a problem because here we're specifying fields, so the order of the fields doesn't matter. It's just checking that it has those fields. It doesn't check that the fields are in the order you specified, because that doesn't make any sense in Perl. And by the way, I don't mind taking questions in the middle of the talk. So if you have a question, just raise your hand and I'll probably...
Very quickly, no plan. That's still...
No, there is currently no plan. If you still load Test Builder, there is a legacy support for things that are already doing no plan with Test Builder, but Test2 does not support no plan. Only if you are actually counting, but you should be using done testing. Unless you're in a very odd situation where done testing wouldn't work.
Oh, I see. So you don't use a plan at all. You use the done testing plan?
Yes.
I get it. Okay. I thought you had to do both.
No. Okay. So anyway, these are the kinds of diagnostics that Test2 provides, and one of the big reasons you might want to switch, like yesterday. To do, Test2 uses a different method of achieving Test2. Of achieving to-do. With test more, you would localize the scoped variable called to-do. It was just kind of a weird interface. With test2, you get a to-do function. First argument is always the reason for the to-do. Then you can pass it a sub, and everything in that sub will be to-do. Or you can capture the return from that, and it'll be in to-do until end of scope. So if you're trying to replace one of those legacy things that use the uppercase to-do variable, you could replace it with this pretty easily without rewriting your code. It's also useful if you've got a test that's verifying stack depth in some way and you don't want to add another scope. So if you're using test2, you need to list it in your build tools what versions of modules you need. What you should do is you should depend on the specific bundle that you are using. Don't depend on Test2-Suite, don't depend on Test2 or any specific versions of those. You should depend specifically on whatever modules you are loading in your test class. So here's an example with Distilla. This is wrong. You shouldn't do that because what's actually inside Test2-Suite might change as it evolves. However, if you require the Test2 v0 bundle, that will guarantee you always have everything you need for that to work. And here's the same example in MakeMaker. Okay, so now you know the basics of writing tests and a few little differences between test more and test2. Are there any questions on this before I move on to a description of the tools? Yes? Yes, this is all online. I'll go back here real quick. test-more.github.io/test2-manual. Oh, that's actually incorrect. But it has a redirect, so you'll be fine. Okay, moving on to the tools. So in Test2, things are divided into a couple different categories or namespaces. The tools namespace is for anything that you want people to bring in that provides functions or the things that are exported for actually making your tests go. These tools generally generate test2 events. Everything in test2 is an event, which is itself an object that gets passed around. So every time you do OK, that generates at least one event. So there's the test2 tools basic. Just about everything here is included in V0. These are just, it gives you OK, it gives you pass, fail, diag, note, to do, skip, all the things you're used to with test more. So I'm going to skip that one because I'm hoping most of you already know what all those do. Test2 tools class is tools that help you verify a class, such as is-a OK and can OK and does OK. Those are a little bit different than the test more counterparts because the test more ones, everyone used them wrong. Is-a OK and test more, the first argument was the thing to check, the second argument was a class, and then the third argument was actually an alternative way of representing the class in diagnostics. But most people didn't understand that and just gave a bunch of things to make sure this is all these things. And test more wouldn't complain about that. It would just pass, even though it might not be true, that it wasn't doing what you want. Whereas can OK has always accepted multiple things to check against. So test more was very inconsistent in its interface. But in test2, these are consistent. Is it OK? First is always the thing to check. Then every single thing you list after that is a class to check against. If you want to give a custom test name, then your second argument should be an array ref, and then your third argument will be seen as a test name. And these are completely consistent, unlike the test more ones. Though test2 wasn't initially released with the array form, so this still listed as new, even though it's been there about 2 years now. I think this microphone is falling. Oops. So the compare tools I'm going to get to in a bit. We already saw a little of them. Defer, most of you will never need this, but if you need to make assertions before you've even loaded test2, such as a case where test2 being loaded will change the results of your tests, you can load test2 tools defer, which will not actually load any test2 stuff except for test2 tools defer. You specify your tests. So here we're defining, or we're saying we want to do an OK. One is the first argument and pass. It'll store that. So if your second argument, if your argument here starts with a function call, it'll store the result of that function call. Then later when you do def, it'll actually run OK against whatever that result was to make sure it matches. So this is where you get to capture the things you want to test, but wait to actually make the assertion later. That way loading things doesn't mess up your results. This is mostly used to test test2 itself, so there's very few cases where most of you will use that. Encoding. Anyone who's tried to change the encoding in test more knows that it is a royal pain. It's very difficult. I don't even have an example up here because it's just full of hoops. With test2, you can simply call set encoding to whatever encoding you want. Done. Test2 comes with exception testers, specifically ones like test fatal, I believe it is. So you actually capture the exception and then you can write tests against it. There is no equivalent of dies OK because there's a lot of really nasty bugs that can come from that interface that I don't have time to go into today. Exports. There are tools for you to check your exporters. Imported OK and not imported OK. Imported OK will only pass if those functions are found in the current namespace. It does not check inheritance, so you can't inherit them. They have to be in the current namespace, but they have to have been defined in a different namespace. If they're defined in this namespace, it will fail because they clearly weren't imported. They were just already there. So it's a really useful check. Ref checking. Since is now a deep check, using it to check that two references are the exact same reference doesn't actually work the way you'd think it would. So we now have ref OK to check that something is a reference or of a certain type, and ref is to verify that two references are in fact the same reference. And ref is not, just because why not? Subtest. There are two ways to achieve subtest in test2. There's using subtest buffered, which is useful if you're in threaded or forking tests, because it won't actually output the subtest until it is complete. That way they don't get all mixed together like they would if you just use test more and forked or threaded. So that's That's the buffered, and then streamed is basically the old style where it's going to output the result as soon as it happens, well before the subtest is done. You do not want to use that if you've got any threading or forking going on. It also has a bunch of tools for testing warnings. I'm not going to go into too much detail here. Just know that if you need to test warnings, you got all the tools you need. Now, any questions on that before I go to comparisons?
Just curious with the self-test, why specify the buffer?
I believe if you load test2 it just gives you subtest and it is the buffered. But if you're loading the subtest module directly instead of going through V0, you have a choice. That's the only reason I listed those there. And some people do prefer the classic stuff. Other questions? Okay, so I've already gone over these compare tools a little bit, but this is the deep dive into the compare tools. You've got is and like, isn't and unlike, and then a bunch of other helpers here that I'll go over in a moment that really make testing deep structures nice. Once again, is and like are now always deep checks. So you can check the state of something. You can say, is this true with the T helper? Is this false with the false helper? Is this defined? And those can be used deeply. Like here we're checking that there should not be a second item in this array by saying does not exist. And here we're checking this hash key does not exist. So that's really helpful. FDNE is false or does not exist. So any kind of falsing value, including not existing, works. So if you don't know if something's going to give you 0, an undef, or just fail to give you the key, that is the helper to use because you don't care which it is. You just care that it's false when something checks to see if it's there. Really, really helpful. I cannot stress how often I use those. So there's also some directed checks. For instance, if you're using is, you wouldn't normally be able to give it a regular expression to match against. However, you can say is match against this regex, and suddenly your is can behave just the same as like for whatever you're checking. You can also do mismatch. You can check that something is the number 12, and then it won't care if it's got decimals or not. And you can check, hey, this thing in string compare, though you could also just wrap it in quotes, so string is kind of useless. You can also check, is the value of this key this exact reference? And it'll check that. Instead of doing a deep dive into the reference, it will check that it's the same reference and then move on, which is really useful if you've got cycles in any of your data structures. And all of these can be used as deep as you want. You can use match 10 levels deep. It just doesn't care, it just works. You can do custom checks. I'm not too fond of this interface, so I'm just going to blast right through this. I'm looking to update that at some point. Sets. You can check that apple is in the set pear, apple, or orange. Or you can check that it's not in the set. Or you can do a check set where it has to match absolutely every check in that set. Those are really useful. So array checks, basically you say, hey, I've got an array. Here's the items. If you don't give it an index, it'll just automatically increment the index for each one. But here I'm saying specifically 3 should be this, which basically means I didn't bother to do a check for index 2 because I did a check for index 0, index 1, then skipped right to checking index 3 because I don't care what's at index 2. And once again, really nice diagnostics if you get it wrong. Hash is not a whole lot different except you use field instead of item. You're required to have a key, and since hashes aren't in any order, you don't give it a numerical value. Also of note, this works for both arrays and hashes. You specify end to say, hey, there should be nothing else in this hash. You can also specify etc as I don't care what else is in this hash, only check these things. At that point, you can basically do the exact same thing in is and like, and the only thing that's different is how strict it is for the stuff you didn't specify directly. We've also got meta check, which lets you check properties of the thing you are looking at. Like, let's check that this is blessed. Let's check that this has this ref type. Let's check that this array is size 4. It also works as a key count on hashes. And this lets you reference the thing itself, so you can nest again and say this should be an array and all that. And there's object checks, and in an object check, you can do either field or item, depending on whether your object is a blessed hash or a blessed array. The prop check from meta checks works fine in objects. And you can also say, call this sub, and this should be the result, or call this method, and this should be the result. And you can even specify a custom sub to call against the object, so it'll do your object, this custom sub, and use it as a method, which is really useful if you have a method that returns a list as opposed to an array ref. You can use this to wrap that. That way you don't need all kinds of fancy things to directly say, hey, wrap this. Meta is specifically it only lets you check for properties of whatever you're looking at, whereas object has a bunch of stuff specific to objects and includes everything meta includes. So you can think of object as a subclass of meta. Okay, any questions on the comparison tools? Moving on, another namespace under Test2 is the plugins namespace. There are a few here that people have been asking for years, but were impossible to do in Test More, such as bail on fail. This plugin will cause your entire test suite to just abort if it encounters any failure. It stops right there with the bailout. There's also die on fail, which is the same except you die instead of bail, and looks like I have a typo there. But these are something that for over 15 years, people were asking for this capability in Test More, and it couldn't be done because you'd make an OK, or the test tool you were doing would do an OK and generate that line of tap, and then things would die, and then none of your diagnostics on why it died would be printed out because those took place after the failure. And so you just couldn't do it with Test More. But Test2 uses a system under the hood that makes this not just possible, but trivial, and it will know when your diagnostics are done because new tools have started, and it will bail after you get your diagnostics, unless you are still using legacy test builder on everything. It can't fix that, but any Test2 tools will finish putting out their diagnostics before the bail. A bailout will completely kill the test suite, like prove or YAF will see it and choose not to run any more test files. Whereas die will abort the current test file, but the rest of your files will still run. Okay, there's also exit summary. This one is loaded by default with V0. It just gives you all the diagnostics you expect after a test is done running. SRAND, this seeds random with the current date. That means that any random behavior, anytime you call shuffle, will be consistent on any given day. So it will always run in the same order if you've shuffled something on a given day. But over the course of a week, it'll have 7 different runs. So you're still verifying random behavior. But if you want to reproduce that random behavior to find out why it failed in a certain run, you can be guaranteed that it's going to have the same seed, which makes it possible to track down a lot of Heisenberg bugs that would otherwise be impossible to track down. And there's a UTF-8 plugin that just automatically makes everything UTF-8.
How do you disable that brand thing? I had one coworker who didn't understand why his tests were producing the exact same results all the time. So I explained it to him, and he wanted to undo that.
So when you import Test2 V0, there is a flag to disable that, I believe. If not, you can just copy Test2 V0, make your own bundle. It's really trivial. I'll be talking about that when I get to the bundles section. Okay. Require, these are, so require is a namespace under Test2. So it's Test2 require blank. And these are to make it so your test is skipped if certain conditions aren't met, such as tests that you only want to run when you have author testing set. You'd require Test2 require author testing. You can also check any arbitrary environment variable. You can skip a test if forking isn't available. This one is a difficult one. Here's an example of the code you would have to write yourself if you wanted a test to skip when forking isn't available. It is this difficult to find out whether or not you have some form of forking. So this plugin just does all this for you, so you don't have to write all that. And then there's real fork, which only lets the test run if your system actually truly supports fork, as opposed to the emulation that happens on, say, Windows. You can also test require module and some module or a given version of it, require certain version of Perl, or require threads. Once again, it's very complicated to check if the current system actually supports threads. So this does all the work for you. Okay, moving on to mocking. Test2 comes with some mocking libraries that are really quite nice. These are based on mock quick, which is a previous mocking module I've written, but this makes up for a lot of shortcomings in that module. So with the Test2 mock tools, you do your mocking and it returns to you a control object. If that control object goes out of scope, the mocking is undone, restoring whatever was there originally or getting rid of everything if there was nothing there originally. So here's how you'd use it. Here's the hard way to use it. Let me clarify. Test2 mock, new, what class, what you want to override, what methods you want to add. There's also a set for if you're not sure whether or not it already exists. But for instance, override will fail if that method does not already exist. Add will fail if the method does already exist. And set is if you just don't care whether or not it's there, you want to override it. And it gives you the control object that lets you then override as many times as you want. You can restore things if you want. You can totally reset back to the original on any method. And once again, once it's out of scope, all the mocking goes away and it cleans up its mess. So you're left in a clean state. So there's also sugar for the mocking libraries. There's the mock keyword, which allows you to do anything. There's mocked to check if something has been mocked. And if you want to be very explicit on what you're doing, you can call mock class or mock object instead of just mock. So here's an example of using that. We're capturing our control object, we're mocking some packages, we're adding the foo method, and we're overriding the bar method. And we can call them, and then we can clear our mock. You can also, you can also say mock class to specify you are mocking a class, or mock underscore class, that other helper. There's Tim Toady here. You can also mock an object directly without creating a random class. Here we're mocking an object. This is the hash that will be blessed to the object, and we want to make sure it has a foo method. And it'll just create that object with a random namespace for you. And questions about the mocking?
Can I make it so that it mocks the class, but only specific methods and anything else will die?
To do that, you'd want to prevent the original from loading, and then you can do that, yes. You can mock a class that has not been loaded.
Are you able to mock a class and make sure that the method you're mocking exists in the underlying class?
Well, with that, you can just use the regular Perl tools and do this object can, and then whatever method you're looking for. Okay, moving on. Those of you who were at Dave Rolski's talk heard him talk about test TCM, test class moose. And this is my competitor to test class moose. So here we go. If any of you have used RSpec in Ruby, this will look very familiar to you. So you can define test blocks. It's with a test keyword, so test foo and then the block and all these. And then done testing is what triggers them to run. And so once it hits done testing, it'll actually run all those subs. You can pass parameters to these subs, such as, oh, this one's flat. That means don't make it into a subtest. Just show it at the top level. You can say, hey, this entire test block is to do, so I'll fix it later. Don't fail when things go wrong in here. You can tell it to skip one. Like, let's say you've got a bug, and if you actually ran that test, it would format your hard drive. You'd want to pop in the skip. Then there's two new ones that don't have equivalents in others. There's ISO, which means isolate this. What that'll do is it'll cause the test to fork, run everything in the fork, and then return control back to the original with those results. That way, nothing you do in that test block can possibly affect the first test block, and unless you share a database handle or something. That way, you are guaranteed that test block will not screw up the environment for any tests that will run later. There's also async, which says you can run this in parallel, you can fork and run this, but you don't have to. And I think I just explained everything in there, so describe. You can create describe blocks, which will group blocks of tests together. And you can nest those. This becomes useful when you then bring in your setup and teardown things, such as before. Before all, run this sub. Before each, run this sub. The difference there is the before all will happen once, before everything runs. Before each will happen before each test block again and again and again. You can group those along with specific test blocks within a describe. So this before all will happen before all these tests. This before each will happen before red, green, blue, as well as before anything in this nested describe block. So it's really powerful. Then there's after, and then there's around. So you can do around all or around each, and that's kind of like Moose's around, or Moose, the things Moose can do there. Though this does not use Moose. None of the Test2 tools use Moose directly. You can still use Moose, but they don't require you to. You can also do cases. Every one of these cases, all the test blocks will run under it. So first it'll set the C variable to red, then run all the test blocks. Then it'll set the C variable to green and run them all again. This way you can test multiple cases with the same set of test blocks. It's really handy. The problem there is if you've got like 1,000 test blocks and 1,000 cases, you're suddenly running, multiply those together. I really suck at math, but it's exponential growth. You can also modify cases. This is where I go a little overkill, and you can do before case and after case and around case. Mocking, the mock tools know when you are in a spec test like this, so you don't actually have to capture control. It'll just know that mock will only apply to the tests inside this describe block. And so mock becomes its own before each or before all. You can still capture the control, but it won't help you much because describe will end before any of the tests inside of it run. There is also Test2 plugin spec declare, which uses devil declare to give you really nice sugar so that you don't have to put the sub keyword or the semicolon at the end of your subs. They work just like any other subroutines now, and it is really useful, and it is really stable despite using devil declare. I've not had any problems with it. Questions about spec, which I highly recommend you use? No. Okay, bundles. Oh, sorry.
So I think you listed that subtest could be declared like asynchronous, that would be like parallelized.
Yes, if you set them to asynchronous, it will automatically, so the default is to do up to 3 processes. So if you're using spec and you specify all your blocks as async, then it will use 3 processes to get through all your tests. And it'll fork to do that. You can disable that if you want, but yeah, so spec does come with some concurrency built in.
You mentioned spec is your answer to test class moves. You're actually using just test class. Have you ever went from that to spec? Is it just such a place like how?
I have never cared for test class, so I'm not the person to ask about that. Most I've done is patch a bug when I was updating things to Test2. So unfortunately, I can't say much about test class.
I mean, you're using it mostly to get stuff like I want to just run this method.
Oh, so yes, with spec, there is actually, I'm surprised I don't have it listed in here. You can set an environment variable with the name of whatever test block or describe block you want to run, and it will only run that instead of running all of them. So you can specify, and I've actually got hotkeys. I press F8 to run whatever test block is under my cursor. And that environment variable can also take a line number, and it'll run whatever blocks are spanning across that line number, which makes editor integration really nice.
So we put each one in a .2 file, so you can first narrow down to like a set of specs, based on .2 and then narrow down further. Environment?
If I understood you correctly, the answer is yes.
Okay, got it.
Okay, moving on to bundles. Bundles are the primary interface when you're trying to use Test2. I recommend you use the V0 bundle. Here's all the things that it imports by default. It gives you strict warnings in UTF-8. SRAND, which it looks like I do not have a way to directly disable that yet. Patch is welcome. But you can specify not to import certain things if you want. But honestly, if you were to look at this code, the bundles are so simple, you could easily just clone it and make a custom bundle. There's the Test2 bundle more, which is the closest thing to the test more interface. If you just want to really quickly convert, you can use test more to Test2 bundle more. But there are a few differences that can still bite you where you'd have to update them, and I've listed those there. There's also Test2 bundle simple, which basically gives you OK plan, done testing, and skip all, and nothing else. Okay, moving on. So now we're getting to a bit of the internals. With test more, for instance, if you wanted to write a helper, so sub helper that makes 5 assertions. So it says okay 5 times. Then if one of those assertions failed, it would give you the line number of that assertion and not the line number of where you called the helper function. To fix that, there was a special variable in Test Builder that most people did not know about, called level in all caps, and you had to localize and increment it, which is not an uncommon pattern in Perl. But it's a really terrible interface, and it's really hard to discover if you don't know it's there. Context is the Test2 solution to this problem. Basically, whenever you are writing a Test2 tool, such as OK, you will pull out a context object which will mark, hey, I'm the top level, so any diagnostic should be reported just above me. Then you can nest functions as deep as you want, and it'll always know exactly where it should actually report the errors. So here's a usage. We're implementing my OK, which is just the same as OK. First thing it does is get a context. Then it can actually use that context to generate events. The context object has an OK method. When you're done with it, you release it. This is important because this is where the die on fail and bail on fail hooks happen. So if you wanted to pop a bunch of diagnostics under this OK line in case of failure, you can, and it will still show those diagnostics, and it'll wait until this release to do the bail on fail. Therefore, you get your diagnostics, and you have a plugin that was impossible with Test More. It is now possible. So rules. There are 10 commandments of the context object. Get it as early as possible. Release it as late as possible. Do not forget to release it. Each sub needs to get its own. You do not pass around a context object. It belongs to the scope where you acquired it and no others. Do not cache or store the context for later use because you will screw up all the things. Do not share a context with anyone else. And it assumes it is being obtained within a sub and not on the package scope. If you need a context at a package scope, you have to pass it some arguments. You do not ever alter the context internals. This is a do not touch zone. And do not monkey patch the context. If you do, I will laugh in your face and tell everyone never use your code. So events get generated. Here's the events I actually recommend you use because these are optimized. It used to be recommended you use context OK. Don't use context OK. Use context pass or context fail because this generates specific pass or fail events that'll get through the system much quicker because it already knows what to do with a pass or a fail event. So your code will be much faster if your test tools use pass and fail as opposed to OK. And I'm not going to get into all the complicated things. So the legacy event generators are OK, note, diag, plan, skip, and bail. But now there's much more optimal ones. And if you go to the Test2 manual, you can see those. Each event has a set of facets. Facets are the actual information that the event tries to convey. The first facet is an about, and it basically says, oh, should we display this? What package generated it? What are some human readable details about this event? Amnesty. This is how to do and skip is implemented. If there is an amnesty object inside the facets, then the event will not actually cause a failure, even if it has failing assertions. An event can have an assertion. It doesn't have to, but it can. This is where it determines whether something passes or fails. You can also give it a test number, and details is the human readable name of that assertion. There's control, which just has a bunch of internals you don't need to know about. Errors, you can add error strings specifically to your event so that you can see, oh, hey, test 2 had an error or my tool had an error that is separate from the actual failure. Like if there was an internal error in your test tool, you could put it in there. Info is how note and diag are implemented, and you can have any number of info items, info facets inside of an event. Parent, so it basically just gives details of, hey, if I am nested, here's how I'm nested. That's for subtests. There's a plan facet that can be thrown in, and trace. Every single event generated by Test2 has a trace that tells you where it was generated. It says what stack frame was it generated in, what process was it generated in, what thread, and then a few internal things you don't need to worry about, whether or not it was a buffered subtest that generated it. And this is really, really handy information. Then I've also got some slides on how to convert. So Many of you are probably thinking, hey, how can I convert to Test 2? Well, first off, must I? No, you do not have to upgrade to Test 2. You already get a little bit of the benefit just because Test Builder now uses Test 2, but I do recommend you convert. However, here's a list of things that were never updated to work with Test 2, and to the best of my knowledge are all still broken. The only one of these that anyone ever seems to care about is Test Aggregate, and I believe someone here is actually doing a presentation on Test 2 Aggregate. I personally do not recommend using aggregates. I recommend you use Test2 Harness instead, which solves the same problem, but in a way that makes more logical sense. And tomorrow morning at 9 a.m., I'm giving a talk on Test2 Harness. Please go to that one. You will not regret it. So I'm not going to go into deep detail on these slides because I want to give you a little preview of tomorrow's talk in the time I have, but this is all online for you to see. It's deep details of what to do if you're actually converting tests. But you're not going to remember them from me talking about it now, so know that there's plenty of documentation online for that. So, preview for tomorrow's talk before we go to questions and answers. How much time do I have?
10 minutes. Well, 5 minutes.
Okay.
And then QA. Split up however you want.
Okay. So Test2 Harness, which I'll be talking in depth tomorrow about, is an alternative to Prove, and it understands Test2 at an intimate level, so it doesn't parse tap. In fact, when you're using Test2 Harness, your tests won't even output tap. They will instead output a stream of Test2 events in JSON format, a JSON-L format to be specific, which the harness can then parse, which gives you lots and lots of wonderful diagnostics abilities. So since most of this is tomorrow's talk, I'm not going to go through all of it, but here's what the output from Yath looks like. It has a quiet but verbose failure mode where any test that passes, it just says, oh yeah, that test file passed. But when a test fails, it outputs everything, not just the standard error. So you get the full details of the test that failed. There's lots of nice features, like it'll automatically time out a test if it takes too long, so you're not just sitting there overnight with a test that locked up. You can preload things to make them run faster. For instance, Moose on this laptop, I think it takes 2 minutes to run the entire test suite. But if I tell it to preload the Moose module and then run the test suite, it takes about 30 seconds, which is really, really nice. We use this at ZipRecruiter where I work to take our test run time on a single box from 4 hours down to just under an hour. That's how useful Yath is there. It's got lots of plugins and stuff, layout, whatever. Most of this you'll see tomorrow, but I also want to give you this preview. There is a graphical user interface to look at the logs that Yath outputs. So you can go, oh, that test run failed. Let's import the log into this tool, and then it gives you this interface for actually inspecting why it failed. Here, it looks like none passed, or there'd be a pass thing here. You can say, hey, filter out these events. So here I'm saying, hey, I don't want to see the plan. I just want to see the failures and the diagnostics. And it'll filter everything else out of your display. The tables that the deep comparisons Test2 does are actually tables in this. This is a web interface. So you actually have a real table instead of some ASCII thing that may or may not fit your screen. Here is a subtest. You can press the plus if you want to see what's under the subtest, but it won't automatically expand them for you. And that's also done via Ajax so that you're not actually wasting time loading things you don't want to look at. So come to my talk tomorrow if you want to see more about how Test2 Harness can really make your life a lot easier. That's at 9 a.m. tomorrow, I believe, in this room. Okay, so now any questions?
What's the URL again for the talk?
After I close it. Okay, come on, why aren't you doing my port? Okay. Oh, it's still in Yath. That's no good.
It's on GitHub, right?
It is on GitHub. Okay, there we go. So
Bottom of there, test one.
there, that's the URL that'll redirect you to the correct URL. Other questions?
This is probably part of tomorrow, but like for showing those deep differences, the table seems like very easy to pinpoint. Is there a more sort of eyeball view, like just kind of like just class these fields out, or something that like is it easy to modify those
I think that might be a bigger question that we'll have to go over after the talk. I don't have an answer for you right now.
Actually, the test2 aggregator, it's something you run under Granum instead of Granum. It's not like the test aggregator.
Okay.
You press pen intervals.
Okay. Okay, cool. Yeah, I'll depending on when your talk is, I'll probably go to it, and then after mine. Okay. Then if you don't mind me heckling, I'll sit in. I'll be nice.
So, I really want to go write some test data. So this is good. The other thing is, so devil declare, reading the flag, it says, if you are using something that uses devil declare, please, for the love of kittens, use something else. So, Chad. Why?
Because devil declare is the only way to add custom keywords consistently across older Perls. Newer Perls have a keyword interface, but I needed those tools to work on older versions of Perl for work, and devil declare to date is still the most reliable way to add a keyword. That said, that is very well compartmentalized magic. It's all off on its side. It's a second thing to download from CPAN. And it's very well encapsulated and tested. I've been using it in production for 7 years now, and I've had no complaints. Line numbers are all still correct. So it works. Can't remember the last time I even had to look at the code. Anyone else? Nope. Okay, then I guess we are done.